All right, the purpose of this video is to show you how to figure out whether a given p-value is less than or greater than our alpha level of 0.05, for example, or 0.01. So if you look at this screen, we have our decision rule is reject if p less than 0.05, and we run our correlation analysis and we get Pearson's R with degrees of freedom 305 equal to negative 0.004 and P equal to 0.438. Now, if you have exam panic or math panic and you suddenly don't know whether this is greater or less than 0.05, I'm going to show you the easiest way to deal with this panic. All right, so let's go over to the right whiteboard. So we have on one side, we have 0.05, okay? In order to reject the null hypothesis, our p-value must be less than 0.05. Okay, so just let's set up, this is just a ratio. We're going to determine which is bigger than which. So it's a little colon here. Our p-value is 0.438, right? Now, this should be obvious, but sometimes we panic and sometimes we haven't had a lot of math. So the easiest way to make this clear is to simply move the decimal point, okay? So remember what we do on one side of a ratio or one side of the equation, if we do it the same to the other side, then the relationship between them stays the same. So if we multiply by 10, if we multiply the decimal by 10, we move the decimal place over 1. If we multiply it by 100, we move it over 2. If we multiply it by 1,000, we move it over 3. And that's what we're going to do so we can completely get rid of this decimal place for both of these, right? We're going to do it on this side, right? Let's add a 0 here. Okay, we moved it over. So now we have a 0, 5, 0, okay? This side, we're going to do the same thing. 1, 2, 3. That's multiplying it by 1,000. So on the other side, we have 438. Okay. Just get rid of this 0. Okay. So we get 50 versus 438. Now it should be clear that 438 is greater than 50. Okay. Because it's greater than our p-value that we obtained. Okay. Corresponding to our t obtained is greater than our alpha 0.05. Okay, we've changed them this way, so we have to fail to reject the null hypothesis. All right,